Hi, it's Elise Naramore, and I'm going to walk you through problem solving, which is learning progression 6 in our class. For all word problems, no matter how simple they are, you have to present evidence of your thinking. I need to see a labeled setup. I need to see what equation you're using, the numbers you're plugging in, and the answer with correct units. Because I don't interview each of you when I give you a question to answer, everything that I know about your thinking has to be on your paper. It's really all about communication. We've discussed the problem solving process, which is the I guess method, right? The setup being the modeling, the illustration that includes the givens, the unknown, right? Any diagrams, right? And then the equation, your substitution, and the answer with correct units. So those are the pieces. So I don't care about seeing your algebra work, but it is a good habit. So the things that you've learned in your math class, you should bring them into your physics class. So you should work vertically down the page because that's the way we read. We don't do math along a row like that. That is a difficult way to organize your work. So, and we don't put things all over in random places because when your work is disorganized, it means your brain is disorganized. It also just makes it hard for me to follow. And one of the key things, as you'll see, is that your audience can follow your work. Again, it's about communication. Thirdly, don't forget for any of these learning progressions, if you don't have enough space on a test or a quiz or whatever, ask for more paper. Please don't stop writing when you have more information just because I didn't leave you enough space. All right, here's the rubric. Again, like I said before, you're going to stop at the level at which you are targeting. When we're going through this video, you can always revisit the video to then look at the next level when you're ready. So the whole idea is for you to understand how do you earn a particular achievement level before moving to the next one. So there's a band, right, that which you will, of proficient. There's like you just made proficient, and then there's you just missed advanced. So you want to, and that's true for all of the levels. So again, just make sure you understand what's required. You may be missing a lot of it, or you may be missing just a little bit. So beginning. I want to see that you're trying. You're attempting to solve the problem. The path you choose may not lead to a relevant answer, right? You might choose an equation. It might be the wrong equation. You might have written out some work. I may not be able to follow it very well because it's disorganized. Maybe you didn't finish it, but at least there's some relevant work there. Developing means that not only are you trying, but there's work there that could produce an answer. And the work is relevant to the question asked. Doesn't mean it's right, doesn't mean it's complete, but it's relevant. Proficient means that you have the whole problem-solving process laid out for me. That's a big leap. Developing, you might have pieces of that problem-solving process, but the proficient level means you have all of the pieces there, although you may have like details that are wrong or missing, right? But the process, you have a labeled illustration, like I could follow your modeling and I can see what equation you use, the numbers plugged in, and the answer with units. So, sorry, not with units. I can see there's an answer and it's answering the question that's being asked. So you're not giving me velocity when I'm asking for displacement, for example. Advanced means you have the entire problem-solving process done because proficient must be met, but everything is right. The diagrams are right, your labeling is right, you have units on your labels, you select the right equation, your algebra is done correctly, you have correct units on your answer, the answer is correct. So listen, you make mistakes in any of those details, you're at proficient. So it's a lot to get right in order to move on. So you have to be able to follow your own work so that you can kind of check and make sure you haven't forgotten any of those details. Expert is when I give you a problem that requires you use multiple topics or multiple distinct steps. So it may be multi-topic or multi-step. So it may be something that I give you an unfamiliar problem. So familiar problems are when they're similar in structure and content to other problems we have done. It doesn't mean they're identical. It just means it's familiar. Unfamiliar would be it's on a topic that maybe we haven't necessarily done, and you can use the problem solving process to actually answer it. I'll show you an example of that. Your strategy is going to be to divide up your workspace into boxes, or like into four. Generally, you've got a corner that's with the illustration, the givens, the unknowns, all your diagrams can go there, and then you have your equation, right, with the numbers plugged in and answer with units. If there are other equations needed, that could go in another box, and you can keep doing that. Just organize your work in chunks. You can actually put lines, make yourself a grid, whatever makes you happy. So we're going to do this example. Let's take a look. We're going to talk about all the levels. It starts with a 10 kilogram mass on a vertical spring vibrates, reaching a maximum amplitude of 8 centimeters. The spring force constant is 100 newtons per meter. How much work did it take to set this in motion? And part B, if the mass is allowed to oscillate freely, it behaves as a simple harmonic oscillator. The period of a simple harmonic oscillator is the time it takes for one complete vibration. The period T depends on the mass as well as the spring force constant as shown in the equation that's now overlapping in my picture. What could a scientist do to the setup in order to double the period of the SHO? So let's go through the problem solving process to tackle part A first. So we always start with a labeled sketch. So let's do that. Here's my ball on a spring. I'm going to label that it's being pulled down to set it in motion. I'm going to make my axis so I know where 0 is. And then I'm going to label my givens. I know what K is, I know what mass is, and I know what the amplitude is. So then I need a free body diagram because, I don't know, it just seems like the right thing to do. There's a force of the spring up and the gravitational force down. Both of those are conservative forces, so those won't do work in and of themselves. Let's set up our energy bar chart. And for the beginning of this, when you're pulling it down, you actually have this force. Oops, I had my eraser on. You have this additional force that's pulling down. So whatever this is, the force of the pull, whoever's pulling on it to get it there. So that's going to be doing some work, which, sorry, I'm going to erase that, but that's going to be doing work in, and that creates your spring potential energy or your elastic potential energy. And this is what gives you your equation. The work in equals your final spring potential. And then you can plug in, because you're trying to find work, you don't need to put in force times distance, and you can just find your 1/2 kx squared, which is the equation for the spring force, plug the values in that you're given, and you can solve for this. Now listen, could I solve for the spring force? Absolutely. It would be F times D, where D is also the same as X, which is the same as A. So you put that in and you can solve for the force. But that wasn't what was being asked for. So now that you've done that, that's the answer to part A. Part B is actually an expert level problem. Why is it an expert level problem? 2 reasons. One is it's about something that we haven't learned in our class. However, I'm giving you the information that you need to figure it out. Let's take a look. How would you solve this? So I would first write the equation I was given, because this sets up the relationship between the period, which is T, the mass M, and K, which is the spring force constant. And they want me to double the period, which means I need to double the variables, right, which is under square root. So I need, 2 pi is a constant. I can't change that. But the square root of whatever's inside of the square root, that whole thing needs to double also in order to make the period double. All right, so now what? So what does that mean? Well, I know that if I need to double something that's the square root, that means quadrupling the numerator, which is mass, or I can quarter k, because dividing something by a quarter is the same as multiplying by 4. So those are my two choices. So I could hang 40 kilograms on the spring, which is 4 times 10, or I can replace the spring with one that has a K of 25 newtons per meter. You can see, I think, why this is expert. It's really pushing you to, first of all, look at how to manipulate an equation to adjust for a change, but you're also using a concept that you haven't used in this way before, right? So that's what makes it expert level.